Hi students, good afternoon. So we are in the session 10 of electrostatic potential and capacitors. And in Canada we'll continue our discussion about the capacitors. Already previous session we started the discussion about the parallel plate capacitor with equal area. Okay, so this is the type of capacitor that we are studying. Okay, so we'll continue our discussion about the parallel plate capacitor with equal area. Okay, so when we look at the capacitor which is charged and sonna anadi one side you will have a positive charge, in one side you will have a negative charge, correct? So if you are having a charged capacitor, right, paranga, if you connect a wire or something from that positive plate up to the negative plate, right, what you will see that there will be a flow of charge that will happen, which means there is a current. So we can derive some electrical energy out of it. So we can derive some electrical energy out of it. Means that charged capacitor is actually storing some energy. Charged capacitor is storing some energy. Okay. What is the value of the energy? So we are going to find what is the value of this energy stored when the capacitor plates are actually charged. How do we calculate the energy stored? Remember, initial class when we're discussing about the method of charging of the plates, what he said, one of the methods of charging is what? If you take small amount of the charge, we will transfer it to the other plate. After some time this will be deficit of the charge. Deficit and negative dana, it will be what? Getting positive charge. So we can keep on moving the charge by small amounts. We can keep on moving. Once the charges are coming, there will be a potential difference between the two plates. So potential difference will represent this by symbol V, right? What will be the potential difference at an instant of time? Let us say charge at a time is small q nichkonga. The potential difference between the two plates will be what? Q by C dana. Potential difference Q by C. Now when you are moving a small amount of charge dq nama move panna, what is the work that has to be done? Because we are moving through a potential difference of V, right? So work that needs to be done is what? V into charge we are moving, which is dq. Okay, va? So V is what? Q by C into dq. This is what is the small work we are doing in moving that charge from the negative plate to positive plate. If you look at the overall method of charging, right, initially and the Q order value is 0. Finally, let us say the charge on the plate is capital Q nichkonga. So the charge on the capacitor plates is varying from angle in there. The charge on the capacitor plates is varying from 0 to capital Q. Capital Q is the final amount of charge. Okay, so finally this plate will have minus capital Q, this plate will have plus capital Q. Okay, va? Now for achieving this charge, we are trying to find what is the work that we are doing. And we are moving the charge from one plate to other plate, right? We have to do the work. So we are going to calculate what is the total work that we are doing. Total work we are doing is what? In the expression integrate. So what is it that we are integrating? Q by C into dq. Limits are for the charge, right? So charge limits are initially capacitor plates are uncharged, right? So 0 up to capital Q. C is a constant. So 1 by C integral 0 to capital Q dq. It's like what? Integral x dx dana. What is integral x dx? X square by 2. Integral x dx and so now what is it? X square by 2 dana. So paranga, what we will get? The work that is done in slowly charging these plates, right, it will be what? Total work done will be what? 1 by C. In the integration of the value Q square by 2, like and the x square by 2 madri. Limits are 0 to capital Q. Paranga, 1 by c substitute பண்ணனும். ஃபைனல் லிமிட்டோட வேல்யூ என்ன? கேபிட்டல் Q square by 2 வரும். மைனஸ் இனிஷியல் லிமிட்டோட வேல்யூ 0 square by 2. 0 square means 0 only. So என்னது? Q square by 2c. So this is the work that is done when we are moving the charge slowly from one plate to other plate, so that finally we are having one of the plates having plus capital Q charge, other plate is having minus capital Q charge. Okay va? So this work that we are doing, right, is getting stored as the energy. So the capacitor is not getting energy from somewhere, right? Whatever the work that you are doing is stored as the energy in the capacitor. So paranga, the potential energy, this is what potential energy. The potential energy is stored by a charged capacitor will be equal to what? Generally we will represent this by the symbol U. Okay, will be what? Why we don't use the symbol E is because generally we will avoid using the symbol E. Already we are using E for electric field, adanala we will not use E, we will use what? U. Okay, the potential energy of that charged capacitor will be what? Enna paranga, Q square by 2c. What is the potential energy stored in the charged capacitor? Evladhi? Q square by 2c. Idukku we also have alternative forms. Alternative forms are enna theriyuma? This formula we will use when we are having the charge on the capacitor plate and adoda capacitance value. Enna formula enna paranga, Q square by 2c irukka. So in the formula nama use pannona, we should know what is the charge on the capacitor plate, and the madri we should know what is the capacitance oda value. We can replace the Q. Paranga, every Q can be replaced as what? C into V, right? Apdi replace panna enna varum? C square V square by 2c. Or C cancel aidum. So half CV square. This is another variation. Idu eppo nama use pannalam? When we are knowing the capacitance value and the potential difference between the plates of the capacitor. Okay va? Ingonu variation irukka. Enna theriyuma? So if you look at this, Q square by 2c, idhula we will replace this C with Q by V. Eppadi we are replacing the C with what? Q by V. Apdi replace panna or Q cancel aidum. In the V mattum numerator la poidum. What is it? Half Q into V. Paranga, these are the three alternative forms. Ellaroda value ore value da, because we are just replacing the relation between the charge, capacitance and the potential difference. So one formula is what? Q square by 2c. When we will use it? When we know the charge on the plates and the capacitance oda value. Other formula is what? Half CV square. When do we use it? When we know the capacitance value and the potential difference. What is the third formula? All are same. All are giving us the same potential energy da. What is the third formula? Half QV. When we will use it? When we know the charge on the capacitor plates and the potential difference. Okay va? So these are the three alternative formula that we can use for finding out the potential energy that is stored by a charged capacitor. What is it? This is the formula for the potential energy stored by the charged capacitor. Paranga. So we can use either half CV square or use pannala, or we can use Q square by 2c. Okay, or we can use half into Q into V. So these are the alternative formulae for the potential energy. Okay, ஏன் நம்ம potential energy ன்னு சொல்லிருக்கு தெரியுமா? Because here this energy, right, is because of the virtue of the state or the configuration. நீங்க பாருங்க, this energy, right, in the formula பார்த்தா it will depend upon what? The capacitance value. It will depend upon what is the potential difference. It will depend upon the charge. So it is depending upon the state of that particular capacitor. Adanala we will call it as what? Potential energy. So what do we call it as? Potential energy. Okay va? So paranga, we look at one sample question. A capacitor of capacitance C is given a charge Q. They are giving a charge Q. Okay va? The distance between the plates of the capacitors is D. So on the rendu plates nodula, what is the distance between the plates of the capacitor? The one of the plates is fixed and the other plate is moved away till the distance between them becomes 3D. Slowly, so let's say one of them is having negative, plate mela positive charge. Okay, so this side will be minus q, this side will be plus q. Okay, now we are fixing one plate, fix pannittu other plate we are moving it so that the distance between the plates becomes what? 3D. Find the work done by the external force. Work done by the external force and so on. They are asking what is the work to be done in moving the capacitor plate. So what is the work to be done in moving the capacitor plate? So initially the capacitor will have a potential energy. Adoda value anna ui and solala. What is it? Q square by 2c. Adana Q square by 2c. We are separating the plates. So initial separation D. Angalendu we are slowly moving one of the plates. One plate is fixed. Ingon plate nama slow move pannirukku. Move pannittu we are increasing the separation to what? 3D. அப்படி நம்ம இன்க்ரீஸ் பண்ண என்ன ஆகும் தெரியுமா? பாருங்க, சார்ஜ் ஆன் த பிளேட்ஸ் will not change. சார்ஜ் சேஞ்ச் ஆகாது. வாட் எவர் த சார்ஜ் ஆன் த கெபாசிட்டர் பிளேட்ஸ் அதோட வேல்யூ சேஞ்ச் ஆகாது. ஓகே, பட் வாட் வில் பி சேஞ்சிங்? த டிஸ்டன்ஸ் பிட்வீன் த பிளேட்ஸ் இஸ் சேஞ்சிங். when the distance between the plates is changing, பாருங்க, capacitance ஓட வேல்யூ சேஞ்ச் ஆகும். so initially capacitance is what? C, right? what is the value for that? if the capacitor plates are having an area A ன்னு வெச்சுக்கோங்க, அந்த வேல்யூ உங்களுக்கு கொடுக்கலாம். but let us say area is A into epsilon naught by D. அதுதான் initial capacitance ஓட வேல்யூ. ஃபைனலி நம்ம பிளேட்ஸ் நடுவில் இருக்க செப்பரேஷன் நம்ம சேஞ்ச் பண்ணியிருக்கோம். சேஞ்ச் பண்ணால் the capacitance ஓட வேல்யூ will change. what is it? area of the plate is not changing. so same area தான். A into epsilon naught divided by 3D. இங்க distance எவ்வளவு? 3D. பாருங்க, this C dash is what? A into epsilon naught by D is C தானா? C dash will be equal to C by 3. so final capacitance எவ்வளவு? C by 3. so final potential energy will be what? இங்கேயும் same charge தானா? Q square by 2 into what is the capacitance here? C dash. பாருங்க, Q square by 2 into C by 3. என்னது? 3 by 2 Q square by C. so initial potential energy எவ்வளவு? Q square by 2C. final potential energy எவ்வளவு? 3 by 2 into Q square by C. what they are asking us? what is the work done by the external force? so how do you calculate what is the work done? so whatever the work done, right? inga enna we will assume that the final state, once we move and fix it, right? நம்ம அப்படி fix பண்ணதுக்கு அப்புறம் there is no kinetic energy involved. and initially both plates are at a fixed separation. finally also they are at a fixed separation, but the value மட்டும் change ஆயிட்டு இருக்கு 3D. so here kinetic energy term is not involved. kinetic energy term is not involved. why? because initially the plates are at a fixed separation, means they are not moving. once we move it, right, we are again making the plates to become static. அதனால kinetic energy ஓட concept இதில் involve ஆகாது. so initially potential energy is there, final potential is there. remember what is the work energy theorem that we will study in the +1 mechanics? what is the work energy theorem concept? work done by the forces will be equal to what? change in kinetic energy plus change in potential energy. அதுதானா? work done by the external forces is equal to what? change in kinetic energy plus change in potential energy. kinetic energy term involve ஆகாது. so that's the reason why change in kinetic energy ன்னு சொன்னா we will take it as 0. வெறும் இந்த potential energy மட்டும் involve ஆகும். so what is it? final potential energy minus initial potential energy. final potential energy எவ்வளவு? 3 by 2 into Q square by C. initial எவ்வளவு? Q square by 2C. பாருங்க, subtract பண்ண என்ன வரும்? 3 by 2 minus 1, which is half. எவ்வளவு? 3 by 2 minus half is what? 1. 1 into Q square by C, which is simply what? Q square by C. so what is the work done by the external force? எவ்வளவு? q square by c paranga. So whatever the change in the potential energy, right, that is what is the work done by the external force. Are you able to get it, guys? So in the மாதிரி question என்ன தெரியுமா, like this is a standard type of problem. They will give a capacitor, other properties they will change, like sometimes they will change the they are changing the separation. We will see after some time they can keep some material in the region between the two plates, right? They can introduce some material. We will call that material as what? Anything other than air, we will call it as what? Dielectric. So they will introduce some dielectric. Then again they will ask what is the work done in the process. Okay, so in the மாதிரி questions எல்லாம் என்ன தெரியுமா, because we are not going to involve any kinetic energy. Kinetic energy oda concept idhula involve agadu. So always whatever modification we do, the work done is what? Change in the potential energy. Based on the work energy theorem, whatever the work done by the external force is equal to what? Actually what is the work energy theorem oda main statement? Change in kinetic energy plus change in potential energy. But inga enna kinetic energy term involve agadu. So adanal we will just focus on what? Veru and the potential energy term mattum. Okay va? So paranga, what is the answer for this? 3 by 2 into q square by c minus half into q square by c. Evlo varum? It will be coming as what? Q square by c. Okay va? So this is the work done by the external force. Adutha paranga, in fact in one of the previous years, right, we got a straight question based on this itself, and the energy density formula mele question vandhathu. Energy density in the region between the capacitor plates. Paranga, when we said there is a potential energy, we said there is a potential energy, right, that is stored by the charged capacitor. Enna theriyuma, that potential energy will not be on the plates. It will not be on the plates of the capacitor. எங்க இருக்கு தெரியுமா? The potential energy will be distributed எங்க? In the space between the capacitor plates. The potential energy will be distributed in the space between the capacitor plates. Okay va? It will be distributed in the space between the capacitor plates. When we look at this energy, right, this is actually distributed as what we call as the field energy density. So what is the exact word that we use? Field energy density. Field energy density eppadi varudhu? Because in the region between the two capacitor plates there is electric field. The energy density is associated with that electric field. Okay va? So we will try to find what is the energy density in the region between the capacitor plates. Energy density and sonna, what is it? Energy by volume dana. Inga paranga, what is the plate area A and the rendu plates naduvula irukra distance d dana. So what is the volume of the region, area of the plate multiplied by the distance. Apdi dana, area multiplied by distance. Adana, that is what is the volume. Inga paranga, it is like a paranga, let's say we take the plates to be circular nechukonga. Area, distance, it's like a cylinder, right? So what is the volume of the cylinder? Circular face area into the length of the cylinder. So that is how we'll get the volume of that region. What is the energy, potential energy value? Already we are having the potential energy value, right? What is it? We are having 3 variations. What are the 3 variations? Q square by 2c, or half cv square, or half qv. Either you can use small q use panla or capital Q, depends upon your comfort. Okay va? So don't think that sometimes you are using small q, sometimes you are using capital Q. So what is this? Q represents charge. Okay va? So paranga, the energy density will be what? Energy density, let us represent this by the symbol rho. Okay, so will be what? The energy value in the form nama use panla. Let us say we will use this one, half cv square divided by volume evlo paranga, A into D. இதுல என்ன தெரியுமா, C ஓட வேல்யூ என்ன, what is the capacitance ஓட வேல்யூ, A into epsilon naught by D தானா. C ஓட வேல்யூ என்ன, capacitance is what, A into epsilon naught by D. substitute பண்ணலாம். A into epsilon naught by D into V square divided by A into D. இதுல A cancel ஆயிடும் பாருங்க. அப்படியே அந்த D denominatorல வரும். half into epsilon naught into V square by D square. என்னது பாருங்க, half into epsilon naught into V square by D square. We can write it like what, V by D the whole square. What is it, half into epsilon naught into V by D the whole square. Okay va? So this is what is the energy density. This is the energy density in the region between the capacitor plates. This is the energy density in the region between the capacitor plates. Paranga, I'll show you the question that has come in the year 2001. Energy per unit volume of a capacitor having area A and separation D kept at a potential difference V is given by. Straight question. Then what is it? What is it? Half into epsilon naught into V by D the whole square. V by D the whole square, or we can write it as what, V square by D square. What is the answer for this paranga? Option A. What is the answer for this question? Option A. Okay va? Ipo enna theriyuma, we'll just try to convert this into one more form. So already we have this energy density. What is it? Half into epsilon naught into V by D the whole square. So we are saying this energy is associated with the electric field. The energy is associated with what? Electric field. So what is the field between the two plates will be uniform. It will be uniform electric field. What is the value of this uniform electric field? It will be V by D. Already in the result nama paathirukom munadi class la. So what is the electric field between the two plates? It will be what? V by D. In case of a uniform electric field, right? If you move a distance D and vechukonga, the negative of potential difference by the distance moved, that will give us what? The electric field value. It will give us what? Electric field in the direction. But namakku enna verum and the value mattum thana venum. So if you take a modulus means that is what? Electric field magnitude. What is the electric field magnitude? Direction namakku theriyum. It will be from positive plate to negative plate. Electric field magnitude mattum evla? It will be what? V by D, where V is the potential difference between the two capacitor plates. Okay. So paranga, அப்படியே அந்த V by D க்கு பதிலா நம்ம என்ன சப்ஸ்டிட்யூட் பண்ணலாம்? E. So what you can write it as? We can also write it like what? Half into epsilon naught into E square. அப்படி நம்ம எழுதலாம். So this formula is in terms of what? Electric field. This result we are going to use. So we are deriving this result by taking the example of the parallel plate capacitor. But wherever we have electric field, wherever we have electric field, right, the energy density is a standard formula. The energy density associated with the electric field. So derivation we have done by using the parallel plate capacitor. But this is a very standard result. For any electric field, இப்போ ஒரு regional electric field னு வெச்சுக்கோங்க, then in that region there will be energy that is spread. For any electric field, the energy density associated will be what? Half into epsilon naught into E square. It's a very standard result. This derivation we have done by using the example of the parallel plate capacitor. But this result, right, will be true everywhere. Like wherever there is electric field, right, on the particular region we will have what? Energy that is spread. The energy density associated with the electric field, adoda value anna half into epsilon naught into E square. Nyamam vechukonga, this formula we are going to again use when we go to the electromagnetic waves. Electromagnetic waves are what? The wave where we have electric fields and magnetic fields oscillating. The electric fields and magnetic fields will be oscillating in perpendicular directions, and wave will be propagating in a mutually perpendicular direction. Wave will be propagating in a mutually perpendicular direction. Angane theriyuma, we'll talk about what is the energy possessed by the electric field part and what is the energy possessed by the magnetic field part. Now what is electromagnetic wave? It is a form of energy, right? Electromagnetic wave is a form of energy. So this concept, right, The energy density concept we are going to use again when we go and discuss about the electromagnetic wave. Okay, va? So this is about the energy density that is there in the region between the two capacitor plates. Okay. So all this time, right, we are saying that the area of the two plates is same. So you have parallel plate capacitor whose plate area values are same. But now practically when we are looking at the capacitors, right, we can have the plate areas to be different in terms of the value. So we can have plate areas of unequal value. So this is like plate 1 and then the plate 2. This can have a positive charge, this can have a negative charge. It is not like every time we have to have a capacitor with equal area. Hard rule. We can also have, but we will not have this in our need syllabus discussion. There is a little bit a higher level concept, but we will have to understand that there can be also capacitors which will have this unequal area. So we can have capacitors having unequal area. Area of the capacitor plates and sonna, we will consider what the effective overlapping area. So area of the capacitor plates, there is an overlap area. So that plate is going a little bit up. Plate 1 is a little bit up. Plate 2 but there is an area that is overlapping. That area that is overlapping, right? This is what we are going to take as the area of the capacitor plates. Okay, va? When the plate areas are different, right? We will look at what the effective overlapping area. We look at what is the effective overlapping area. Okay, so this is how we look at the capacitors having equal or unequal plate areas. But namakarana maximum we'll have only what the parallel plate capacitor with equal area. Idhula nama focus pannanum. Okay, but just as an idea, right? What is it that we are going to do? We will have to consider the effective overlapping area and the value the area of the capacitor plates. Okay, va? So next thing is the charging of the capacitor. Every capacitor charge by connecting it to a voltage source, which can be a battery or it can be a cell. So when you are charging it, right, the positive terminal of the battery and the one plate will get the positive charge, and the negative terminal and the other plate will get the negative charge. Okay, so this process is going to take some time. So that period where it is getting charging, right, we will call it as the transient state and solution. Transient state and solution, the period when the capacitor is getting charged. Okay, we'll discuss about it separately. Transient state we'll discuss about it separately. But if we look at the steady state, think of it like what the final state. So final state is that state where the capacitor is fully charged. The state where the capacitor is fully charged. When that happens, the potential difference between the capacitor plates, the potential difference between the capacitor plates will be equal to the voltage of the source. So whatever the battery or the cell, whatever using, right, whatever once it is fully charged means no more charge is able to go. What is it? The positive terminal of the battery will be at the same potential as the positive plate of the capacitor. And negative terminal of the battery will be at the same potential as the negative plate of the capacitor. So the potential difference between the capacitor plates will be equal to what? The voltage of the source. That is what we'll be calling as the steady state. Okay, so once in the steady state reach then the charge value, we can straight away say what is charge value going to be? It will be what? C, which is the capacitance, multiplied by the V. What is V? The source voltage. Why? Because in the steady state or the final state, the potential difference across the capacitor plate will be equal to what? The voltage of the source. Okay, so the steady state charge value will be equal to what? It will be C into V. Steady charge it will be C into V. Okay, so once the capacitor is fully charged, appa enna solunga, there will be no more flow of charges through that branch. So whatever the branch, in the branch namakku capacitor vechirukku theriyuma, whatever the branch where you are keeping the capacitor, no more flow of charge. And the particular branch lo flow of charge irukadu, which means what? There will be no current. Current will be zero. So that is the reason why we call the capacitor as circuit breaker. We call it as what? Circuit breaker. Because once the capacitor is fully charged and the particular branch kulla current pogadu, which means what? It is like cut off. Physical connection irukku, but in terms of electrical and the analysis no current will go through it. So it is like that branch is actually cut off. So that is another important point we have to keep in mind. And I think in one of the AIMS paper we got question on this. So when you have a capacitor in steady state and solvanga, so when they say the word steady state, means what? Capacitor is fully charged, so in that particular branch, right, no more current will go. In that particular branch, no more current will be going. Okay, so we'll see one example like that when we go to the next chapter, current release chapter. We'll look at some example on that. Okay, wow. So this is what is the concept of the steady state or the final state of the charging of the capacitor. This is the final state of the charging of the capacitor. Okay, ingane theriyuma, once we charge the capacitor, so inga nama transient state adu pathi nama inga discuss pandrathu kedaiyadu. We will discuss about it separately. The transient state pathi we will discuss about it separately. Okay va? So once you charge the capacitor, right, we can leave the capacitor like that by connecting across that voltage source. Apadiye nama connection, we will allow the connection to stay as it is. Apadi vecha enna theriyuma, if the voltage source is kept connected to the capacitor, அப்படியே நம்ம கனெக்ட் பண்ணி வச்சா, then the potential difference on the capacitor plates, will remain same as V. So it has already got a potential difference V, right? That is going to remain same. It is going to remain constant throughout. When we keep the capacitor அப்படியே connect பண்ணி வச்சா, it will be maintain the potential difference between the plates to be same. Okay, அப்படி இல்லாம we can do one more thing. We can just disconnect. What is it? Disconnect ன்னு சொன்னா, we just cut off the we just cut it off. Cut பண்ணா, what is it? The capacitor is now disconnected. இங்க பாருங்க, this plate will have a negative charge, this plate will have a positive charge. Okay, so maybe other way around, but one plate will have positive charge, one plate will have negative charge. Okay va? Now once you disconnect it, right, the charge on the negative plate and charge on the positive plate are going to remain constant unless you connect something across them. நம்ம ஒன்னும் கனெக்ட் பண்ணலாம்னு வெச்சுக்கோங்க, அப்படியே நம்ம டிஸ்கனெக்ட் பண்ணி விட்டா, then what is going to happen? The capacitor plates, அதுக்கு மேல இருக்கிற charge values, right, they are going to remain the same. So if the capacitor is disconnected and let like that, so அப்படியே நம்ம விட்டா, what is it? Charge on the plates remains constant. Okay va? Charge on the plates remains constant. இந்த ரெண்டு பாயிண்ட் ஞாபகம் வெச்சுக்கோங்க, because these points will be useful in the next set of discussion. Okay, so another first is what? If you keep the capacitor connected to the battery, அப்படியே நம்ம கனெக்ட் பண்ணி வெச்சா, what is going to happen? The potential difference across the capacitor plates will remain the same, which is equal to the voltage of the source. Okay va? அப்படி இல்லாம what is the other way? Once it is charged, we can disconnect பண்ணா, if you don't attach anything to it, don't attach means what? Charge and the capacitance அப்படியே இருக்கும், it will remain constant. Okay va? So this is about the charging of the capacitor and what we can do after the charging. Charge பண்ணதுக்கு அப்புறம் what we can do generally, either we can let it like that, அப்படியே connect பண்ணி we'll just leave it like that. அப்படி வெச்சா then what, the potential difference will remain same as the voltage source. அப்படி இல்லாம if you disconnect பண்ணா, the charge and the capacitor plates will remain the same when you let it like that. திருப்பி நம்ம இங்க ஒரு ஆப்ஜெக்ட் ஆர் whatever other thing you நீங்க கனெக்ட் பண்ணி வெச்சுக்கோங்க, then there might be some changes, but அப்படியே if you just leave it like that, right, isolated நம்ம leave பண்ணா, then you know what is going to happen, the charge value on the capacitor plates will be remaining as it is. Okay va? So this is about the thing that we can do after the charging. So this is a very important model of question. ஏன்னா நிறைய தடவை previous yearsல கேட்டிருக்காங்க this particular model. என்னது பாருங்க, connecting a charged capacitor across an uncharged one means what? So இப்ப நம்ம கிட்ட ஒரு capacitor என்ன வெச்சுக்கோங்க, it is charged. Charge means what? One plate will have a positive charge, other plate will have a negative charge. அப்படிதானா? Let us say இதோட capacitance எவ்வளவு, C1 வெச்சுக்கோங்க. The potential difference is what? V1. We are bringing another capacitor. Let us say the capacitance is C2. இதுக்கு மேல charge கிடையாது. Charge is not there means what will be the potential value? Potential also will be 0, right? Charge is not there means potential is also what? 0. Potential difference is what? 0. Okay. So here what is the potential difference? 0. ஏன்னா charge கிடையாது. Now look at it. We are connecting the charged capacitor, we are connecting across the uncharged. Charged capacitor, we are connecting across the uncharged. அப்படி connect பண்ணா what is going to happen? பாருங்க, positive plate of the capacitor 1 இருந்து அப்படியே இந்த positive charge இந்த பக்கம் வரும். Not fully but some amount. அந்த மாதிரி இங்கல இருந்து negative charge will come onto this plate, which means what? There will be charge redistribution. அப்படி சொல்லலாமா? What is going to happen? Charge redistribution. Till when? Till both the capacitors reach common potential difference. அதோட value V ன்னு வெச்சுக்கோங்க. What is V? V is what? The common potential difference. அப்படிதானா? Because charge transfer will keep happening till both the capacitors having the same potential difference. So the positive plate of this capacitor and the positive plate, they will be at the same potential. அந்த மாதிரி negative plate of this capacitor, negative plate, they will be at the same potential. Okay, அப்படினு வெச்சுக்கோங்க. Then look at it, what is going to happen? Initially what is the total charge? ஏன்னா இந்த C2 க்கு மேல charge கிடையாது. Initially what is the charge? Initial charge எவ்வளவு? What is the initial charge? வெறும் இந்த C1 V1 மட்டும், because charge on that capacitor 1 is what? C1 into V1. Final total charge எவ்வளவுன்னு பாருங்க. ஏன்னா finally we have charge on the capacitor 1, and the மாதிரி there is a charge on the capacitor 2 also. What is it? The final charge on the capacitor 1 எவ்வளவு? C1 into V. V is the common potential. Okay, இங்க என்னது பாருங்க, C2 into V. For the second capacitor, what is the charge? அதோட capacitance value into potential difference. Potential difference எவ்வளவு? same தானா? That is what we are calling as the common potential. That is what we are calling as the common potential difference of the capacitor plates. இப்ப பாருங்க, whatever is the initial charge, right, அதுதான் redistribute ஆயிட்டு இருக்கா? Whatever the charge on that first plate, some of it is going to second plate. The charge on the first plate, right, some of it is going to second plate. அப்படிதானா? So which means what? The charge value initially whatever you have should be equal to the final charge. The initial charge, right, that is the one that is getting redistributed. அப்படிதானா? So which means initial charge எவ்வளவு பாருங்க, C1 V1 is equal to what? Final charge is what? C1 plus C2 into V. This V is the common potential. So எங்களுக்கு என்ன தெரியுமா? We can find what is the common potential value. எவ்வளவு? C1 V1 by C1 plus C2 is the common potential. Then the common potential. Okay, so this is what is the common potential that will be there on both the plates. In fact, this is what is asked in one of the previous years also. Capacitor, the capacitance is C1 is charged up to a voltage V. It is charged up to voltage V and then connected to an uncharged capacitor of capacitance C2. The final potential difference across each of them means they are asking us what? They are asking common potential. Okay, the formula na V common is equal to what? C1 into other initial potential V divided by C1 plus C2. This is what is the final common potential. Paranga, what is the answer? It is option B. Okay, they can make some more questions. So this is the question that has come in the previous year, but they can ask some more variations. So look at this. Capacitor 1 so in the problem this problem we are done. So capacitor 1 charge is flowing up to capacitor 2. So definitely when the charge is flowing through that wire, there will be the energy losses. So they can ask us what is the energy losses. If we connect panna, they can ask us what is energy losses. Initial energy namakku theriyum. Initial energy will be what? Energy on the first capacitor. First capacitor is the one that will be charged. Na solradhu indha maadhiri model. So one plate will be uncharged initially, one of it will be charged. So initial energy will be on only one plate. Final energy, both the plates will have final energy. Capacitor 1 will have final energy, capacitor 2 also will have final energy. When we say energy loss on sonna, final energy will be lesser than the initial energy. So if you do initial energy or value minus final energy, that is what is going to give us the energy loss. So if they're asking us to calculate energy loss in Hkonga, how we will find the energy loss? Initial energy or value minus final energy. Okay, so that is also another possible question. So we will try to work out an example on that. Look at this. Charged capacitor with a capacitance C is charged by connecting to a battery of voltage V. Okay, so like we are connecting the capacitor of capacitance C to a voltage source V. So final potential difference across the capacitor plates will be what? V dana. Then after disconnecting it, it is connected across an uncharged capacitor of capacitance 2C. Paranga. Discharge pannittu we are connecting it across what? So this is capacitance C, initial voltage V. Capacitance 2C, initially uncharged, means potential 0. Okay, find the energy loss during the charge rearrangement. What is going to happen from that capacitor 1 angalandu? We will see some charge will flow to the capacitor 2. What they're asking what is the energy loss during the charge rearrangement. First we will calculate what is the initial energy. Initial energy will be only on one capacitor 1 dana. So what is the capacitance of the value C? Potential difference V. What is the energy formula? Half CV square. Let us keep it as equation 1. So we know what is the initial energy. Initial energy will be only on the capacitor 1. Energy. Capacitor 2 is uncharged, so that will not have any energy. Okay, so once we connect it, there will be charge rearrangement. We can find what is the common potential. V common and solid, or we can say VC, common potential. Finally both will have the same potential. Other formula the charge on the first capacitor, which is C into V divided by total capacitance value, which is C1 plus C2. So I am going by the previous formula. We derive formula. What is it? The first capacitor capacitance value into other potential difference. This is nothing but what? Charge on that first capacitor, because initially charge is only on that is the total charge actually. So total charge divided by sum of the capacitances C1 plus C2 இங்க பாருங்க. So C plus இங்க என்னது 2C, C into V by 3C, C will cancel ஆயிடும். So common potential value எவ்வளவு? V by 3. Common potential value எவ்வளவு? V by 3. இங்க பாருங்க. Now we will write the final energy. Final energy will be what? Half into C into, for the first capacitor, what is the potential here? V by 3, right? V by 3 the whole square, half CV square formula. அந்த மாதிரி second capacitor, half into 2C into V by 3 the whole square. Okay, so what is it? அவ்வளவுதான். இந்த வேல்யூ அப்படியே நம்ம சிம்பிளிஃபை பண்ணி we will be able to know what is the final energy. Final energy will be on both capacitor 1 as well as capacitor 2. பாருங்க, what is it that is going to come? The V by 3 whole square common எடுத்தா வெச்சுக்கோங்க, half நம்ம common எடுக்கலாம். So what is it? Half into V square by 9. Common எடுத்தா what you will have? C plus 2C, which is 3C. So half V square by 9 into 3C. 3 1s are 3 3s are எவ்வளவு? 1 by 6 into V square into C. This is what? 1 by 6 CV square. Equation 2 anu vechikalam. This is what? U final. Idan the U initial. They are asking us what? Energy loss. Energy loss will be what? Energy loss and keta, what is it? U initial minus U final. And a loss and நம்ம எப்போ சொல்லுவோம்? Like when you are doing a business, right? You have initially more money. Business பண்ணதுக்கு அப்புறம் you are having less money means that is loss, right? So if I am asking you what is your loss, what you will do? Initial minus final money, அப்படிதானா? So initial energy எவ்வளவு? Half CV square minus final energy எவ்வளவு? 1 by 6 CV square. So CV square common எடுத்தா 1 by 2 minus 1 by 6. What is 1 by 2 minus 1 by 6? பாருங்க. So if we take an LCM means 1 by 2 minus 1 by 6, right? LCM எடுத்தா what you will have? This is 3 minus 1 by 6, that is 2 by 6, that is 1 by 3. எவ்வளவு வரும்? We will get it as what? 1 by 3. Okay va? So which means 1 by 3 C into V square. This is what is the energy loss during the charge rearrangement. So ஒரே ஒரு பாயிண்ட் நம்ம ஞாபகம் வச்சுக்கணும். What is it? Whenever we are having this energy loss question, right, we will have to find the common potential. Common potential find out பண்ணதுக்கு அப்புறம் what we will have to do? We will have to calculate what is the final energy values on both the plates. அதை add பண்ணா we will get what is the total final energy. Initial energy we have to subtract it. Subtract panna we will get what is the energy loss. So where this energy will go? Where this energy will go? This will go in and the connect panna wire theriyuma. So whatever the wire or thing that we are using to connect both the capacitor plates, the energy will be dissipated. The energy will be dissipated in the form of heating of these wires, etc. Okay va? So this is the method to find energy loss during the charge rearrangement. So first step to calculate the common potential. Common potential வந்ததுக்கு அப்புறம் we will calculate what is the energy on each of these plates, energy on each of the capacitors. So the energy loss will be what? Energy loss will be what? Initial energy minus final energy. ஓகேவா? ஸோ அடுத்த கான்செப்ட் பாருங்க. இதுக்கு முன்னாடி என்ன, one capacitor charged, second capacitor uncharged. ஓகே, அதுலேருந்து இங்கே கொஞ்சம் நம்ம காம்ப்ளிகேட் பண்ண வச்சுக்கோங்க. we can have both the capacitors already initially charged. இங்க பாருங்க. so there is a capacitor C1 with a potential V1. இந்த பக்கம் என்னது பாசிட்டிவ், இந்த பக்கம் நெகட்டிவ். we can have capacitor with a capacitance value C2, அதோட initial potential V2. okay, இப்படி நம்ம கனெக்ட் பண்ணா this is called as what, connecting like charge plates. they will actually give this wording also. Another, when you connect the capacitors, right, we are connecting the like charge plates, means positive and positive connected, in the bucket negative and negative connected. okay, so appa enna theriyuma, the initial charge on this will be what, பாருங்க, what is the charge on this, q1 எவ்வளவு, c1 into v1, அந்த மாதிரி q2 எவ்வளவு, c2 into v2, and the charge that will be redistributed. so maybe some positive charge will come from here to here, and the மாதிரி some negative charge will come from here to here. so there will be some readjustment till both of them will have the same common potential. let us say V is the common potential value வெச்சுக்கோங்க. V is the common potential. இங்க பாருங்க, initial total charge plus and plus are connected, like charge connected, minus minus connected. so initial total charge எவ்வளவு தெரியுமா, it will be q1 plus q2. so q1 plus q2 which will be equal to what, c1 v1 plus c2 v2. final total charge, and finally both the capacitors will have the same common potential, which means charge on the capacitor 1 எவ்வளவு, c1 into v, அந்த மாதிரி charge on the capacitor 2 எவ்வளவு, c2 into v, because they both will now have the same potential. there will be no charge loss, right, there will be no charge loss, which means what, whatever the initial total charge will be equal to final. பாருங்க, c1 v1 plus c2 v2 is equal to what, இந்த பக்கம் நீங்க v காமன் எடுத்தா c1 plus c2 into v, அதுல இருந்து நமக்கு காமன் பொட்டன்ஷியலோட வேல்யூ வரும் பாருங்க. so what is the common potential value, அப்படியே நீங்க அந்த ரைட் சைடுல இருக்கிற c1 plus c2 லெஃப்ட் சைடுல கொண்டு வந்து வெச்சுக்கோங்க, it will go to the denominator. so what you will have left side la, c1 v1 plus c2 v2 divided by c1 plus c2 is the common potential. this is what is the final common potential. okay va? so idhiliyum they can ask some questions like that. everybody they can ask what is the energy loss, energy loss and keta, what we are going to do, we will look at what is the initial energy on both the plates. inga enna theriyuma, initially also both the plates will have energy, and the madri finally also both the plates will have energy. so enna pananum, initial energy minus final energy, that is what will be the energy loss. okay va? so what is this, this is connecting the like charge plates together. idhila you can have one more case, enna theriyuma, so look at this, we have the capacitor C1 with a voltage V1, in the bakka positive, in the bakka negative. second capacitor we will connect it exactly in the reverse manner. reverse manner sonna, the positive idanadi, idoda capacitance is C2, initial voltage is V2. we are connecting, what we are doing, we are connecting the unlike charge plates. so this is what this way of connecting is called as what, connecting unlike charge plates. நீங்க இந்த வேர்டிங்ஸ் மேல ஃபோக்கஸ் பண்ணணும், கண்டிப்பா இந்த வேர்டிங்ஸ் நம்ம மறந்து கூடாது. so what is the first wording that we said, connecting like charge plate ன்னு சொல்லுவாங்க, இங்க என்னது connecting unlike charge plates. இப்படி கனெக்ட் பண்ணா what is going to happen, பாருங்க, இங்க என்ன இருக்கா, பாசிட்டிவ், இங்க என்னது நெகட்டிவ். so they will cancel each other, they will nullify each other. பாருங்க, this is q1 வெச்சுப்போம், this is q2. so q1 எவ்வளவு, c1 into v1, q2 c2 into v2. இங்க என்ன ஆகும் தெரியுமா, one of them will be higher, either q1 will be higher or q2 will be higher. the net charge. Cancel ஆனதுக்கு அப்புறம் what is the net charge going to be? நமக்கு தெரியாது. Maybe Q1 can be higher, maybe Q2 can be higher. We don't know which is higher, right? அதனால தெரியுமா, we will put modulus. We don't know which is higher, right? அதனால we will put modulus. So what is it? Modulus of C1 V1 minus C2 V2. So the net charge available எவ்வளவு? Plus minus they will cancel. If Q1 is equal to Q2 னு வெச்சுக்கோங்க, then what happens? They will fully cancel. அவ்வளவுதான் முடிஞ்சது. If Q1 is equal to Q2 means they will fully cancel. But they are a different value means they will what? Partially they will cancel. So some amount of charge will remain. There will be some value for the net charge. Okay va? So net charge எவ்வளவு? Modulus of Q1. ஏன் நம்ம modulus யூஸ் பண்றோம்ங்க? Because we don't know which is higher, right? Maybe Q1 ஜாஸ்தி இருக்கலாம் or Q2 may be higher. அதனால we are keeping a modulus. So this is what is the net charge. Okay. This net charge will be redistributed. So let us say V is the common final potential in H. So final charge எவ்வளவு? C1 into V plus C2 into V. ஏன்னா both of them will be now at the same common potential. So அதனால charge on the capacitor எவ்வளவு? C1 into common potential value V. அந்த மாதிரி charge on that capacitor plate 2 எவ்வளவு? C2 into common potential value. Okay. So இப்போ same தான, whatever the net charge that is remaining அதுதான distribute ஆயிட்டு இருக்கா. So which means what? Modulus of this C1 V1 minus C2 V2 is equal to what? C1 plus C2 into V. So இங்க பாருங்க, we are looking for what? That common potential value, right? We are looking for what? Common potential value தானா. So common potential value எவ்வளவு வரும்? We will get the common potential value as what? நம்ம எழுதலாம். What is the common potential? இங்கேயும் அப்படிதான். Just bring it to the left side. அது denominatorல போய்டும். So modulus of C1 V1 minus C2 V2 divided by C1 plus C2. இதுதான் common potential. Okay. இதுக்கு வந்து difference என்ன? In that first case நம்ம like charge plates connect பண்ணா charges are actually adding on to each other. Okay va? So adhanala what is it that we got in the previous case? What we got? Common potential value எவ்வளவு? C1 V1 plus C2 V2 divided by C1 plus V2. So inga charges ரெண்டு add ஆயிட்டு இருக்கு. But இங்க என்ன? We are connecting unlike charge plates. Unlike charge plates connect பண்ணா charges will cancel each other. எது ஜாஸ்தி இருக்குன்னு சொல்லி நமக்கு தெரியாது. அதனால we are taking what? Modulus. So whatever the net charge remaining, right, that will be distributed. That will be distributed on both the plates. Okay, அது அப்படியே distribute ஆயிடும். So this is about the connecting of these capacitors. Okay, so maximum we will have up to this level. Both the main என்ன தெரியுமா? We will have the previous நம்ம டிஸ்கஸ் பண்ண கேஸ் என்னது? One of them will be charged, இன்னொன்னு என்னது? Uncharged. அந்த ரெண்டும் கனெக்ட் பண்ண மாதிரி. That is the standard model. Okay, அந்த values and the results நம்ம கண்டிப்பா பிராக்டீஸ் பண்ணணும். அதுக்கு அடுத்த ஸ்டேஜ்ல we will have these connecting of the two charged capacitor. அதுல என்ன? நம்ம ரெண்டு விதமா கனெக்ட் பண்ணலாம். One, connecting by having the like plates, like in the first case மாதிரி. அப்படி கனெக்ட் பண்ணா what is the common potential? C1 V1 plus C2 V2 by C1 plus C2. இன்னொரு விதமா நம்ம கனெக்ட் பண்ணலாம். Connecting the unlike charge plates together. Then there will be charge cancellation. இங்க என்ன வருது? common potential value modulus of C1 V1 minus C2 V2 by C1 plus C2. Okay va? So this is about the connecting of the capacitors. The next class we'll continue some more discussion. And the capacitor, I think at least we'll have another 2-3 classes போய்டும். So this is the last concept, right? The electrostatic potential and capacitor is the last concept, capacitor. We'll get a lot of scope for having questions. That's why we'll spend some time on it. Okay. So in the standard results, நம்ம derive பண்ண formulas எல்லாம் நீங்க கரெக்ட்டா ஞாபகம் வச்சுக்கணும். Maybe what you can do is for every chapter, right, ஒரு formula sheet மாதிரி நீங்க ஓனா நீங்க எழுதி, you can just keep it so that before you go for the final exam, right, you will be able to easily revise those things. Okay, bookல இருக்கும், but என்னன்னா when you write it by your own hand, right, that will make you to recall the things more easily. Okay, there is some psychological thing also involved in that. Okay, so we'll see in the next class.